Spring is in the air, but not necessarily in the ground. Glancing into a local catch basin, I was surprised to see a frozen waterfall of icicles just below the lid. That the ditch above was flowing implies a big drop in temperature right at the boundary. So how could it be warm enough for snow to melt above, but still freeze solid below? The secret lies in the soil just under our feet. At the start of winter, when the air temperature dips below freezing, the water in the soil starts to freeze too. But rather than solidifying all at once, that freeze happens gradually. The longer it stays cold, the deeper that freeze progresses. Different soils freeze at different rates, and the deepest ice at any given time is known as the frost depth. In the spring, when the air temperature gets above freezing, the soil water starts to melt, but from the top down, meaning deeper soil layers can stay frozen longer. That's why the ground feels extra spongy and soft in spring. The melting water at the surface is trapped by the ice layers below. In fact, if I dig down here, you can see the ice in the soil. But that's a terrible idea since I live in the city and there's just a maze of pipes, cables, and infrastructure below my feet. My neighbors wouldn't be too pleased if I cut both their internet and their sewage at the same time. But that begs the question. If the ground is frozen, why doesn't the water in those pipes freeze as well? The answer here is engineering standards. In most places, we've observed how deep the frost line has been in the past, and then required any new pipes to be built below that limit, so they're less likely to freeze in winter. That's no guarantee, of course, as friends of mine in Texas found out during a winter storm in 2021. Normally, mild winters in Texas meant that pipes were just 30 centimeters below the surface in some places. When a 10-day cold snap in February 2021 pushed the frost line unusually deep, frozen pipes disrupted water service to more than 12 million people. The main thing is, the soil below us isn't static. It's an ever-changing system hidden just out of sight. But, just like spring, the more light we can shine on it, the better we'll see what lies beneath.